Hi, this is swathiramya, Assistant Professor AIDS Department from SNS College of Engineering. You are here with me in IOT lecture series. In the previous video, we were discussing about the physical design of IOT and what all the interfaces available in the physical design of IOT has been discussed and told many times. We have 7 interfaces starting from the connectivity, processor, audio video interfaces, input output interfaces, memory and storage interfaces, graphics interfaces too. With this, and we were discussing about the layers. Okay, these layers are common layers that you have been read many times in the network, your network subjects. Only thing is what kind of protocol and what all the things technology you are going to use for IoT will be specified, or which technology or which way of communication will be suitable for IoT, that will be described in these layers. So we will have 4 layers. This is a 4 layer. You have 4 layers in it, that is starting from the link layer, network layer, transport layer and the application layer. In the previous video, I were discussing about the link layer, the main responsibility of the link layer, how the physical transmission is going to happen, what kind of medium we are going to use, and what kind of protocols, what kind of technology we use, and which technology is more apt for IoT system. These all we discussed in the previous video. So in this video, we are going to discuss about the next layer, that is network layer. So when it comes for the network layer, it is from the name it is very clear. See, the network layer, the responsibility of the network layer is to send and receive the data using the help of IP datagrams. Here you will have a datagrams. The datagrams will have the source address and destination address. That is called IP datagrams. You will tell it as a IP datagrams. Will have source address and destination address. It has a source network and destination network. Here you will do what all the responsibility of network layer is. It will find the route. It will try to find the minimal route to transfer the data, to transfer these packets from the source to destination, and it has addresses also to identify the devices. This is the main, this is the main use of network. This network layer will handle the addressing. Number 1, addressing. Number 2, routing of the data packets between the devices on different networks. First thing, you need to know address, where to go. So this network layer will give you the addressing. It will add, you have a packet, you have to transfer the packet from say one device to other device. So what it will do, it will take the packet, it will add its source address and it will add the designation address too. So with the help of this idea, it will helps us to addressing. Next, route. It will find the shortest path, or it will find the route to reach the destination. So it will do it have 2 tasks, addressing and also routing of this data packets inside the network. So for this we can use protocols. We can use a protocol called IPv4, Internet Protocol version 4. This is the fourth version of the Internet Protocol, widely used to identify the devices on the network and using the addressing system. And next protocol will be IPv6, Internet Protocol version 6. This is also the very recent version of the Internet Protocol, which is designed to address the limitation of IPv4, such as address exhaustion. See, when you go for IPv4, you have the issue of addressing. It could not able to address more number of devices. But when you go for IPv6, it can able to address millions of devices. So addressing is very, very important when it comes for IoT, because we connect n number of devices here. So you need more number of devices to get addressed. So IPv4 is fine for small level of IoT system. When you go for high level of IoT system, IPv6 is the best choice because it will give you number of it does not it does not have any limitation for addressing capabilities. So due to the lack of addressing capabilities of IPv4, they have been launching new version of Internet Protocol version 6, that was Internet Protocol version 6. Then there comes the 6 LOW path, which is nothing but Internet version protocol 6 over the low power wireless area network, low power wireless personal area network. This allows IPv6 packet to be sent and received over the base over the network. Okay, this allows the IPv4 6 to send and receive the data based on the networks, which is used for low power and low data rate low data rate communication. See, there is a difference between IPv6 and difference between IPv6 and 6 low PAN is nothing but here also we use IPv6, but it is low powered and also the low data rate. So that will be the different. So when you compare all these three things, this is low PAN is very useful for IoT system because it takes less power. So that is why it is called low power. In IoT system we need low power things because it runs 24/7. So we need low power things. So low PAN will be very useful for IoT system. Okay. So we have been discussing three protocols. When you compare all these three protocols, IPv6 will be very apt for most of the IoT system. When you go for low level IoT system, IPv4 also very suitable for that. When you have more number of devices, we need to go for IPv6, and when you have the low power things, power problem, then you can choose low PAN also, low PAN for network layer. Okay. With this I will wind up this session. The next session I will discuss about the other two layers. Bye bye. See.